Hi, my name is Phil Yules and I'm the author of MultiQC. I work at the National Genomics Infrastructure, which is a genomic sequencing lab which is part of SciLifeLab in Sweden. We process projects from research groups across Sweden of all different types, and as well as the library prep and sequencing, we also do bioinformatics analysis for groups to a descriptive level. Part of that involves doing lots of quality control to make sure that the data that we send to users is of high quality. When I started at the SciLifeLab, much of that was done by reading results from text files through the command line. This is very difficult, especially with the large numbers of samples that we process, and generally made everyone who's involved with this pretty sad. So I started MultiQC as a project to try and visualize this data and plot it and make it easier to understand, and hopefully make everyone enjoy their lives a little bit more. From the start, MultiQC was designed to work with multiple samples and also multiple types of input and give a single report at the end of that so that the overview of the entire project can be seen in one go. MultiQC doesn't run any tools itself, so you have to still run the analyses yourself first. It doesn't, on the whole, calculate any statistics of its own. It tries to just collect summary statistics generated by each tool. And it's standalone, it works offline, and it doesn't require any external dependencies. So it generates an HTML report which you view in your web browser, but it doesn't actually use the internet. I started the MultiQC project about 2 years ago now, with this original kind of mock-up, with the idea being just focused around FastQC at the time and being able to skip through multiple plots with examples of what's good and bad data looks like. It's progressed a lot since then to one of the first working versions and through to the current reports, which look something like this. MultiQC is written in Python, and when you generate a report, it recursively searches through all of the files on the path or paths that you give to it. Each tool that it supports, each bioinformatics tool, the code for that is contained within a module. So each of those MultiQC modules parses the content from those log files. And then MultiQC templates take that information and render the HTML report which MultiQC produces. On the front end, within the report, the CSS is handled by Bootstrap as an underlying framework. All of the dynamic plots are generated using highcharts, and there's quite a lot of custom JavaScript, which is usually built with jQuery and a few other plugins. Highcharts gives interactive plots, so the raw data from MultiQC is embedded in the report in JSON format, and it's then plotted in the HTML. One of the problems that can happen is that if you run MultiQC with very large numbers of samples, hundreds of thousands, this can be difficult. And so the header of a slide does it scale. We have to really think about what will happen when people run MultiQC using very, very large numbers of samples. To help highcharts and stop it from crashing your browser, when we hit a certain number of samples, MultiQC instead uses matplotlib and generates static image plots. The advantage of doing this is that a plot is always pretty much the same file size, irrespective of how many samples you use. So the file size becomes independent from the number of samples instead of growing, as it does with the raw data. It also means that your browser can easily render the report quickly without taking too long or crashing. There's visualization challenges with scaling too. If you have thousands of samples, then tabular data can get really difficult to understand, and there's just too much data for you to take it in. So one of the other features of MultiQC is to use instead a B-swarm or a dot plot to visualize that same data when you hit a certain number of samples. And this gives you an ability to see an overview of the value distributions and spot any outliers. It's exactly the same data, I just changed the way it's visualized. If this still isn't enough and all of the data that MultiQC passes out of text files is saved as raw data files, and the advantage of this is that there's a single consistent data structure style, and you can choose whether you want this as comma separated or tab separated, which is a default, or JSON or YAML. And this means that MultiQC can be a very easy middle step for data processing. If you're using a single cell experiment, you can run MultiQC to normalize all of this information so that you can easily do downstream analysis. These three things mean that you can run MultiQC effectively with thousands or tens of thousands of samples, and it will take a long time to run, but it will hopefully give you useful output. So it should scale well, we hope. One of the main challenges with MultiQC is sample names. If we have a FastQC report such as this, it's pretty obvious what we should use as a sample name. We can just cut off the end of a file name, and that gives us something which is useful and hopefully consistent across different modules. MultiQC has a number of pre-configured suffixes, so that this is obviously, when we look at it, we can see it comes from the same sample, and underscore deduplicated is in the list of suffixes which can be removed. So MultiQC gets rid of this. But it can be a lot more difficult than this. Sometimes we get input files which have nothing to do with the sample whatsoever. And in these cases where it's possible, MultiQC modules try to find a sample name from within the file. If the input file name is listed, then it will try and use that instead of the log file name. Other problems which are impossible to solve from MultiQC are whether you want to merge files or not, or whether you can have multiple outputs from the same sample name. Here, for instance, we would end up with two different samples, even though they're the same originating. And this can mean sometimes that, for instance, the general statistics table, which contains information from multiple modules and sources, can have blank rows and duplicated rows, which can be difficult to overcome, such as this. So we can see on the left-hand side, because there's two FastQC reports for every sample, we have those blank rows where there's only one set of alignment results per sample. This sample name cleanup is one of the hardest things in MultiQC. And so sometimes there's some degree of configuration required, where in order to get a really nice clean report, you might need to add to the MultiQC config the parts of your file name or sample name strings that you want to remove or truncate, so that all of your samples get collapsed into a single logical entity. So in order to do that, here we could add to our MultiQC config file, just say remove _1 and _2 from the file names, and then we end up with an identical file name for read 1 and 2. And what happens is, if MultiQC finds the same sample name more than once, it just overwrites whatever it finds before, which you can see in the verbose log. And now we have a nice table where we have one row per sample. And this is one of the classic configuration tasks that many MultiQC users need to do to get a nice output. On the topic of configuration, the aim with MultiQC is to have sensible defaults wherever possible. I try to make MultiQC as easy to run without any configuration or setup needed. So when you run MultiQC with the current working directory, as simple as you can possibly get, it should hopefully usually work and give you something sensible. However, while that's a great approach, I also try to make everything as customizable as possible if you want to. And so you can write YAML customization configuration files, and you can configure nearly everything that MultiQC does. So you can really fine-tune the output of MultiQC to what you want. As an example of this, this shows the header of a report for Regenerate at the National Genomics Infrastructure, and this contains quite a lot of customization. For starters, there's a title, a report title here, which we've added, and a subtitle, which wouldn't normally be in the project. And you can see on the top left, this is the configuration file that we use to do this. We also have some introductory text and a custom message which can go underneath. You can do -- title and -- comment on the command line if you'd like to add these without having to write a configuration file. We've also added our own custom logo in the top of the report, and that has a link and some hover text, so that we can link, if anyone clicks on that image in the report, it takes them to our website. Finally, there's this section of kind of meta information which is on the project level, so it's not on the sample level, and you can add whatever key pairs you like here. So we've added kind of an email address and an application type, but this is totally arbitrary. So this is if you have extra information that you'd like to save into the report, so report level, you can put this here into your config file. One of the recent additions to MultiQC is a new module called Custom Content. And the idea of this is that it's a generic parsing module. So if you have a custom script which produces some output that you'd like to have in your MultiQC report, you don't have to go away and write any Python code or create your own module. You can just customize the formatting and the file naming of that file, and MultiQC should be able to pick it up and put it into the report. And generally, if ever you add on _mqc.text or .csv or .yaml or whatever file name extension you need, if it ends in _mqc, MultiQC will hopefully find it. And without any other configuration information, it will try and guess and do the best thing it can for that file. Here you can see one such file. We've got an _mqc.text, and you can see that we've got some information about a lane and some reads and whatever. It's a tab delimited file. We've also added a couple of comment lines at the top here, and these are MultiQC configuration lines, and it just tells MultiQC that this should be a table rather than it having to guess. And it also gives it a name so that the section in the report is called lane statistics. But this could be, again, whatever you want. And if you look on the MultiQC documentation website, this lists everything, all the different possibilities here. It doesn't have to be a table. You can do bar graphs and line graphs, any type of plot that you can do in MultiQC, heat map if you want to. And this file shows a bar graph. We've got a little bit extra configuration here, configuring how the plot title and the y-axis label. Pretty much everything you can configure in a MultiQC module can be put into these files, so you can add as much or as little configuration as you like. MultiQC is built in a very modular way, and one of the advantages of this is that you can write your own custom plugins in Python. This is an excerpt of a setup.py file for anyone familiar with Python that you use to write a Python package. This MultiQC uses setup tools, and it has a number of entry points, and you can plug into these entry points to get your own custom code to run. Here you can see that there's CLI options, command line options, so you can use that to add extra command line parameters. And the hooks underneath are different points in the MultiQC execution where you can name your own functions, and that code will be run in the main MultiQC run. So if you set this up properly, then all you need to do is install MultiQC, install your plugin, and then your custom code will run at the same time every time MultiQC is run. And this is great because you can keep your code separate from the main MultiQC codebase, and so you can continue to have updates and not worry about overwriting what you've done. And of course, if ever you want to bring your own code into the main MultiQC tool, if it be useful for other people, it's very easy to do so. An example of some plugins that have been written, this is one we've just recently released, which talks to the Clarity LIMS system by Genealogics, now owned by Illumina. One of the things that this plugin does, is it takes the sample names that MultiQC has found in your data, and it searches the LIMS database for these. If it finds matches, then it can pull back project level information to put into the header of the report, and also sample metadata such as values from the laboratory. And it uses the Genealogics API to retrieve this information. It requires a small amount of configuration just to tell the plugin how your LIMS is set up, but hopefully is pretty easy to use. So if that's of any interest to anyone, we'd love some testers. Other people have written a module for BC Bio, which is a pipeline tool. They've written additional modules which are specific to the results generated by those pipelines, as well as customization of how MultiQC works, how the reports look. And we have a plugin that we've written specifically for our sequencing facility, which does works with our in-house LIMS database and our in-house results, both to pull information and change for instance, the report file name, so that the file name is always named after the project, but also saving results from MultiQC back into our database and onto our web server so that we can interrogate the data from MultiQC kind of over time and across multiple projects. At the moment, we're working on a big extra package, which is tentatively called MegaQC, may end up having a different name at the end. And the idea behind this is to collect results from multiple MultiQC runs so that you can visualize trends across any kind of different output in your data. This would run locally, it's not on the World Wide Web, but hopefully it would be a really useful tool to interrogate quality control metrics over time. And just to give you an idea of roughly how it may end up looking, this is just a basic mock-up. You might be able to choose different types of plot, choose the samples you want to show, and then plot data across lots and lots of different time points. Okay, that's everything from me. MultiQC is available through a Python package index and also through Bioconda, so you can install from whichever is your favorite with a single command. All of the source code is on GitHub. We also use pull requests if you'd like to contribute any code, and issues if you'd like to report any bugs or ask for any new features. The MultiQC website is multiqc.info, so go there for documentation and instructions and everything to do with MultiQC. I'd like to thank the people that I've worked with, so for the rest of the group, my boss Max at the NGI and other people in my group who have worked on the project, and also for very many contributors through GitHub who have written code which has become part of MultiQC. I've put a few of their pictures at the bottom there, but there's many more as well. And everyone else who's just emailed suggestions or reported bugs or in any way been involved with the project. You can contact me via email. My GitHub username and Twitter username are there, so please do get in touch, and I'd be happy to hear from you, and I hope MultiQC is helpful.